Hello there. Let's continue our networking conversation for A+ with cables and connectors. Now, if you're new to this series, do me a favor and subscribe and like the video if you're enjoying this content. And that'll help you not miss the next one. So first, let's talk about the Ethernet standards. Now, this is going a little bit into the Network Plus space, but of course there's going to be a little bit of overlap between CompTIA A+ and CompTIA Network Plus, as Network Plus is the expected next step in the journey. So the Ethernet standards we're going to be looking at are developed by the Institute of Electrical and Electronic Engineers, the IEEE, and they define most of the OSI Layer 1 and Layer 2 things. And the standards you're going to see quite a lot will be Ethernet with 802.3. Now, just to quickly break that down for you guys, the 802 code, that's just the year and month that the IEEE brought out the first networking standard of theirs. And all of their networking standards always begin with an 802. So just use the 802 to recognize its networking. And then the .3, well, that's Ethernet. Now, the IEEE defines the baseband frequencies, and those dictate the speed and performance of the cables. So you'll often see a number, base, and something at the end of the word base. Now, the word base just describes base bandwidth. Thankfully, we don't have to worry about what the frequencies are, although you can go and look them up if you're curious, but it will not be in the A+ or even the Network Plus exams. Now, usually the number at the beginning of this naming convention is the speed in megabits per second, unless otherwise stated, like, for example, 10G base for 10 gigabits per second. And then the thing at the end usually indicates the media type. It will either be letters, in which case the letters T or F will indicate twisted pair or fiber optic. And if it's any other letters, it's probably fiber optic. And then the alternative to letters is a number. And if you see a number, that means it's a coaxial cable. And that number is telling you how many hundreds of meters the cable is good for at a single length, before the signal will degrade to the point that it cannot be properly processed on the other side. So let's work our way from old to new with coaxial. So coaxial cables are a little bit old, but managing to hang on and still have some useful and niche applications. So coaxial cables will look something like this, with a central copper conductor, an inner insulator, some sort of metallic shielding, which is one of the reasons why they're quite useful. They're quite immune to electromagnetic interference. And then there'll be an outer plastic jacket to keep it all safe and protected. So it has that single conductor in the middle. Now, with one conductor only to carry a signal, that means it can only handle half duplex communications. In other words, we can only communicate in one direction at a time, either send or receive. We can't do both. It's one or the other at any given point in time. And there's two main varieties of coaxial cable for Ethernet and communications, and that is 10-base-5 and 10-base-2. Both offering us 10 megabits per second, 500 meters for 10-base-5, and 200 meters for 10-base-2. And this used to be used for Ethernet LAN cabling, but thankfully we've moved on from this. But we still do see it used for cable TV, internet, and antenna for things like satellite dishes and certain kinds of wireless access points. Now, if you do end up dealing with coaxial cables in networking, you'll usually have either the F-type connector, the B and C connector, or the Type N connector. Generally, B and C and Type N tend to be the most common nowadays in the networking space, with the F-type hanging around for things like cable TV and satellite connections. Now let's move on to something a little bit more modern and relevant, like twisted pair. So with twisted pair, what we have is the most common LAN cable currently in use today. And it's commonly called an Ethernet cable, which you can forgive people for, as the term Ethernet started becoming very widespread and recognized around the time that this cable was also becoming popular. Now, what makes it appealing to us is it is cheap if you make it yourself. It gives you a good variety of speed options. It allows for both half and full duplex communications, and with full duplex communications, what we have is the ability to send and receive simultaneously. You also get pretty reasonable cable lengths, around about 100 meters, under ideal circumstances. but generally it's a good practice to terminate the cable before you reach the 100 meters mark. And it is made up of 8 color-coded wires, usually twisted together in pairs. The twisting is there to eliminate crosstalk, or interference that the electricity flowing through one wire can cause with the other wires. And it also helps to minimize on external interference in the case of things like unshielded twisted pair. Now, before we start looking at the cable itself properly, let's just talk about the CAT standards that they come in. The CAT standards are there to describe the speed and capabilities of a twisted pair network cable. And CAT 1 gives us 1 megabits per second, and it's a telephone cable basically. CAT 2 is 4 megabits per second, it was digital telephone. CAT 3 is when we properly started doing that 4-pair or 8-wire cable for Ethernet LANs. And it gives us 10 megabits per second up to about 100 meters under ideal circumstances. CAT 4 gave us 16 megabits per second, and it was only used by token ring networks. Now, CompTIA doesn't really want you to worry too much about CAT 1 through to 4. I just tell you about them so you know where we came from. CAT 5 is the lowest level you'll need to worry about for A+ and even Network Plus, offering us 100 megabits per second at 100 meters, and it got labeled Fast Ethernet for LANs. CAT 5e, or the enhanced version, is able to go up to 1000 megabits per second, but it doesn't do it very well. You'd be better off going for a higher CAT standard like CAT 6 for a guaranteed 1000 megabits per second, or 1 gigabit per second if you prefer. But it is quite commonly used in most residential and small business networks nowadays. CAT 6 is the one that can guarantee you a smooth, clean 100 megabits per second all the way up to 100 meters. And it is recommended to use it for commercial applications, such as in office networks. Then you got CAT 6A/E, giving us around 10 gigabits per second, but not very stably or consistently. And it's usually recommended for medium-scale data centers and core infrastructure in a relatively large office network. CAT 7 does the 10 gigabits per second better, and it's more suitable for that type of usage, as CAT 6A/E is. And then we have CAT 8. CAT 8 has 2 varieties actually. 8.1, which can give us 25 gigabits per second, and 8.2, which can give us 40 gigabits per second. But only up to 30 meters, not 100. But in a data center, or the core of your network infrastructure, 30 meters between devices is still pretty significant. This limitation that I keep telling you about, it's between powered network devices. So there can be 100 meters, or in the case of CAT 8, 30 meters, between a desktop and the switch, and then another 100 meters before the next device. Again though, I just want to reiterate that those are under ideal circumstances and conditions. Generally, it's better to chicken out and terminate the cable somewhere before that ideal max distance. Usually, I would say around about 90 meters for normal Ethernet, and then about 25 to 27 meters for CAT 8. Now, unshielded twisted pair is the cheaper of the lot. It looks something like this. These are our 8 lovely little wires twisted together in color-coded pairs. Usually you'll have a solid color and a white mixed color. So brown, white, brown, blue, white, blue, green, white, green, and orange, white, orange. So these 8 wires are in the 4 color-coded pairs, and the amount of twisting is different per pair. You thankfully don't have to know how many twists there are per foot or per meter. And the twisting allows us to practically eliminate the crosstalk and is able to ignore minor external interference, making it ideal for office and residential applications, as that type of interference you would get in your average office building or home network. The unshielded twisted pair's twisting is more than adequate to deal with. The pricing is pretty reasonable, but it obviously does go up in price as you go for the higher CAT levels, because the higher CAT levels offer you better performance. And it's relatively easy to work with. Then, for environments where you're going to get interference, shielded twisted pair is an alternative. It still has 8 wires in the 4 color-coded pairs, but it includes some kind of metallic shielding. You get a foil wrap or FUTP, foiled unshielded twisted pair, where there's a metal foil and wire around the inner wires. And then you get true shielded foil twisted pair, where it's got foil around each pair and a braided metal shield around it. Either way though, both have metallic shielding. You must use a shielded RJ45 connector with them though. Without the shielded RJ45 connector, the metallic shielding is not able to properly absorb external electromagnetic interference and send it to ground. So if you use your ordinary all plastic body RJ45 connector, the shielded twisted pair cables are not going to work nearly as well as they should. There are actually a couple of other varieties of shielded twisted pair, but those two photos are the most common that you would likely to come across. And it drastically reduces and even eliminates minor to moderate levels of external interference, making it suitable for industrial environments and other electrically noisy places that you would want to run a network cable. Then you get Plenum and riser rated cables. Plenum rated and riser rated cables are both for safety reasons. We install Plenum rated cables in the plenum space, which is usually raised floors and suspended ceilings, whereas riser cables usually are installed in the vertical spaces between the floors of a building. They are both offering us fire resistance with the intention of trying to stop the fire from spreading, and as you can imagine, in a multi-story building that would be very important to do. But also, the Plenum rated cables offer low toxicity and meet health and safety standards for fire safety. And the riser cables also meet fire safety standards. So it's an extra attribute you might want to pay attention to when doing structured cabling. Now for the connectors. On the left here we have a standard RJ45 connector, all plastic body with the contact pins for the wires. On the right hand side, this is what a shielded RJ45 connector looks like. As you can see, it still has a plastic body, but along the sides it's got some metal for that shielding in the cable to be attached to. This metal will make contact with the side of the network card, which is usually grounded with the rest of the computer case, and it allows the shielded cable to then send the interference somewhere. And then now for the fun of making one. So when you are doing structured cabling, you at some point are going to have to terminate your own RJ45 connectors. Believe you me, it's a lot cheaper to make your own cables than to pay someone else to do it. And we have particular patterns to follow, 568A and 568B. If you look closely at this picture here, you'll notice that the patterns are almost identical. It's just the green and the orange pair that swap around. The blue and the brown pair stay exactly where they're meant to be. But in terms of building your own cable, you look at your RJ45 connector. Pin number 1 is the leftmost, pin number 8 is the rightmost. Please make sure though that the hole or opening for the cable to go into is facing downwards and the little plastic latching clip is facing away from you. When you need to make your own cable, you will strip away the outer insulator with a cable stripper. You will then untwist and separate the wires into individual strands. Try and get them into the right pattern between your thumb and finger, and then trim it to length. Slide the wires into the RJ45 connector, and then once they're properly seated, you insert it into a cable crimper and squeeze it. It will take a bit of practice in getting used to, but once you get the hang of it, you can make your own network cables relatively easily. Now, the idea is that you should be using the same pinout on both sides to make what we call a straight through cable, where pin 1 on the one end matches pin 1 on the other. 568A tends to be more popular in North America. 568B tends to be more popular in Europe, but it doesn't make too much difference as long as you keep the same pattern on both ends. If you switch it around, we've created what we call a crossover cable. So if you use pattern A on the one end and pattern B on the other, you have made what's called a crossover cable. The intention of a crossover cable is if you're connecting two identical devices together, like two switches directly to each other, or two computers directly to each other, and those devices don't have something called auto MDI or auto MDIX, which is where the network card can actually intelligently swap around the pin functions for transmitting and receiving. Don't lose too much sleep over that though, that's more of a Network Plus concern. Now for fiber optic. So fiber optic cables are the fancy new alternative to copper-based cables like coaxial and twisted pair. The basic construction of a fiber optic cable goes something like this. You will have an optical core in the middle, around which we have something called cladding. The purpose of cladding is to first of all act as a bit of a lubricant so that nothing causes abrasion or wear on the optical core, which could affect light. And also the cladding will reflect light back in case the light travels at an angle and hits the edge of the core. The cladding acts as a reflector too. Around the cladding is a coating to protect it and keep it safe. And then there'll be some sort of strengthening layer like Kevlar fibers to keep it nice and safe. And around that will be a jacket to keep it all weather resistant and safe from the environment. But that is a basic fiber optic cable. Now that's the primary construction of a fiber optic cable. You might have multiple core cladding coating layers put together to create a multi-strand cable, which is a lot easier to install than having loads of tiny little loose fiber optic cables all over the show. It also might include some copper for power delivery to a device further down the cable. The purpose of delivering power will be so that something can improve and optimize the light transmission going through a cable, which is what's going to make the fiber optic WAN cables that travel between the continents possible. Now, fiber optic cables come in two main varieties: single mode fiber and multi-mode fiber. Single mode fiber has an optical core of around 8 to 10 microns, whereas multi-mode fiber has a 50 to 60 micron core. Basically, it's smaller for single mode and larger for multi-mode, the core that is. Single mode fibers also use a laser-based emitter, whereas multi-mode fibers use a diode-based emitter. If you look at any powered appliance near you right now, it usually has some sort of power indicator light to let you know the thing's on. It's a very similar electronic component to what is showing you that that thing near you is turned on right now. In short, an LED. Now, single mode fiber cables tend to be more expensive, whereas multi-mode is usually cheaper. The expense, though, in single mode fiber makes it suitable for long distance uses, for WANs and other kinds of things like that. Whereas multi-mode fiber is better for shorter distances because it's cheaper, making it ideal for LANs. But beyond that, there's actually a lot of various types of fiber optic cables. What I would suggest, though, is consider bringing in an expert when it comes to installing fiber optic cables. They are finicky and difficult to work with, and the sheer variety of cables makes it a challenge to deal with. I mean, we've already got 3 fiber optic connectors to choose between. You've got the SC connector, or the subscriber connector. I always remember because it looks like a square connector. You get the LC connector, or the lucent connector, which is very, very popular in WAN connections. And then you get the straight tip connector, which is sort of like the BNC/F-type connector for coaxial, except it's got a fiber optic core. Again, it's definitely worth bringing in a fiber optics expert to install these cables, because even the connectors can be quite finicky to work with. And considering the expense, even though multi-mode fiber can be a lot cheaper, fiber optic cables in general are still a lot more expensive than twisted pair network cables are. And usually you would want to use this in the core of your network where all traffic converges in an enterprise environment, or in a data center where all the servers are connected. And again, if you're going to do cabling like that, you want to get a very, very good job done, so bring in a fiber optic installation expert to do this for you. Trust me, it's a lot easier. But that's the basics of your network cables that you need to know about for A+. You will learn more about network cables and the media when you do a course like Network Plus, but for now, that is plenty. I hope you found this video helpful, and I would like to thank you for watching. If you have any friends, family members, colleagues, or peers that would also like to do the CompTIA A+ exam, don't be afraid to share this video with them. Otherwise though, I'll catch you in the next video.